to learn how to configure them. And configuring of ACLs is very easy. And I want you guys to basically learn how to do that. So this is configurations of ACLs for IPv4. Configuration for ACLs for IPv6 was taken by Cisco to CCNP, and that's where we're gonna find more details. By the way, as Kenyatta University, I think currently I'm the only one certified to teach this, both CCNP ENCO and CCNP NRRC. That's for routing and switching for CCNP Enterprise. And you welcome those who want CCNP classes. I will also be offering that on behalf of the university. So that is good news that we did have recently. Anyway, so I mean, in terms of configuring ACLs, we are going to learn how exactly do we implement ACLs to filter traffic and secure administrative access. And part of the objectives for this particular activity is we will configure standard IPv4 ACLs to filter traffic to meet networking requirements. All right. We'll also use sequence numbers, and I'm going to tell you guys what sequence numbers are. We'll use it to edit the existing standard IPv4 ACLs. We'll also configure a standard ACLs to secure VTY lines. What is that again? Yesterday, for those who are in class yesterday, we did learn a very interesting skill. We did learn how to configure SSH, and of course, I'm gonna be doing soon. I'll do a video on YouTube for SSH configuration and merits and demerits of having, SSH in contrast to Telnet. And for those who are there, yes, in our practical class, we of course did configuration for SSH Telnet. And so, why do we say Telnet is insecure, and why do we say SSH is more secure? Of course, I will demonstrate that. For those who are not there, I think you'll have the advantage to just get to watch and get to learn more about that. We'll also configure extended ACLs to filter traffic according to network requirements. Very, very important. You'll also get, the advantage of configuring ACLs. There's a lot of work that I'm gonna be giving you guys. Now, for ACLs, since when you're using it in a production environment, we must pass through a simulated environment like Packet Tracer. So this is the first instance where I think Packet Tracer still works. In fact, Packet Tracer will give you more activity, more practice than even, when doing it on real devices, even though we will do it at some point. But I want you guys to take your time. For the time I've been teaching about ACLs, I've found my students benefiting more when they work out the Packet Trace activities that I have assigned them. They have more practical experience than the practical lab that we'll be having. That doesn't mean that we won't work on one of them. We will be combining ACLs, and we will use it with the NAT. Of course, NAT is the next topic, which is network address translation, which also uses NAT. So we're gonna configure it, but in the next chapter. But I want you guys to take it upon yourselves to have more practice on the packet trace activities that I'll be giving you. And I'll start from very simple to complex. Simple to complex. Basic standard, named, standard numbered. Then you go to extended numbered, and then you go to extended name. So just pay attention, and I'll give you some few examples here, just to be able to open your eyes and to be able to take you through the nitty-gritties of configuring SSH, and thereafter you will definitely do a good job. I have no doubt in my mind. So let's first start by creating ACLs, which are access controllers. Now, like I mentioned before, these configurations must be planned, guys. I mean, this is something that needs serious planning, and you must sit down with your board of governors. You must sit down with your other members of the department, and you must read the security policy very well, and you must get input from all the other members within your organization, so that you know it's also another way of if mistakes are made, you get to own the mistakes all together as a team, so that the mistakes are not put on you. But like I mentioned, your text editor, and the simplest text editor doesn't come from heaven. Use Notepad. Notepad is available in all Windows machines. All right. To implement some of these policies, you need to then add the commands on the Notepad to accomplish these tasks. Make sure you include remarks to document or to describe your ACLs. Then you need to, like I said, use a simulation environment like Packet Tracer or GNS3 to test your ACLs. Then thereafter, when they are working and they're doing what they're supposed to do, then you can now copy and paste the commands into the device. All right. And of course, like I mentioned, test them thoroughly. And you don't want to make some of these mistakes, because you will not like the result. You definitely won't like the results. So let's start with the numbered standard ACLs. That means ACLs with the numbers. So I, of course, need you to pay great attention here. We want to create an ACL number, and if you can remember, standard is basically from number 1 to 99. From number 1 to 99 is standard ACL. So you'll say access list 10, and by putting 10 there, it means it is a number between it's a number between 1 to 99. So access list 10 remark. The moment you see the word remark here, then that's how you know this statement here is not going to permit or deny anything. This remark is just used to describe your ACL. It's just being used to describe your ACL. Just being used to describe your ACL. Okay. So as access list 10 remark, then what follows after the remark is just a sentence. I mean, it's just telling us what this ACL is going to be doing. So it says ACE, which is of course access control entry, permits only hosts, and this is the host IP 192.168.10.10 to the internet. So we are going to permit only one IP address, which is one device basically, from accessing the internet. Probably this, if it's at home, this can be maybe this is a child that you need them to do some homework, so prevent them from accessing the internet, or this is a computer that need not to access the internet. So the second statement is now the statement that will do the actual permitting or denying. So you say access list 10, and the word that follows here is permit. By the way, there are only 3 words that can follow after the 10. Either you say permit, or you say deny, or you say remark. Remark is just a description. Remember the way we describe an interface, we say description. So here we say remark, and then you give your description there. Then access list 10 permit, and you're going to permit. And this is where I need to start throwing some points at you guys. Like I told you, access list they use wildcard masks. All right. But if you are referring to only one IP address, which is, when I talking about one IP address, it means it's one device, because one IP, one device. So when you want to permit or deny only one particular IP address, you don't need to put the wildcard mask. You can start with the word host. Okay, say permit host, then you put the IP. You are also allowed to use the wildcard mask. Only that when you use the wildcard mask for one particular IP, you use a code 0 wildcard mask. So you're gonna say access list 10 permit. You don't use the word host. So you say 192.168.10.10 space 0.0.0.0. That is, the wildcard mask for a single IP address. So you have 2 ways of configuring a single host address. If you say do show access list, I want to confuse you a bit. You'll see standard IP access list is access list number 10. But the actual access list is actually here. 10, permit 192.168.10.10. Please do not be deceived. This 10 does not refer to the number of the access list. This 10 is what we call a sequence number. For every access list statement of either permit or deny that you put, the access list will always give it a unique number. All right. It is given some kind of numbering system. I mean, if you want to know that, let's first look at the second example. We say access list 10, remark. So this one will permit all hosts in LAN 2. That is the function or the explanation of what it's going to be doing. So the actual access list is access list 10, permit. We are now going to permit the whole network here, 192.168.20.0. When you're using permitting or denying a whole network, then you must use the calculated wildcard mask. So 0.0.0.255, it means the subnet mask was /24, which is 255.255.255.0. All right, so you put the wildcard mask there, so that when you say do show access list, you now have the second one is here. Look at the sequence number it's given. It's given sequence number 20. It's given sequence number 20. And so it's say 20 permit the whole of that network there and the wildcard mask, which are actually here. Now, listen to this. Just by configuring these statements here, nothing, it's like you've done nothing yet. All right? It's like you've done nothing yet. And what happens is that until you place this ACL on a particular interface, and this is very important, by configuring this list, your router will not permit to deny anything. Like I'm telling you, it's like having security guards and you build for them a house inside your home and you close for them inside that home and you tell them now guard my home. So we go to the interface serial 0/1/0, for example, and you say IP access -group. This is how we implement the ACL on a particular interface. Here we say access -list, but on the interface we say IP access -group. All right, you must put the number of the ACL, which was number 10, and then you must put the direction. Very, very important. If you don't put the direction, of course, the command will not be permitted. So say IP access -group, put the ACL number. If it was a name, you will put a name here. Then you must say whether the access list is in or out. Outbound, it's out means it is outbound. In means it is inbound. And I'm going to show you, of course, how to do that. I'm going to show you how to determine whether it's out or it is in. All right. Now, let's look at a named one, a named ACL. For a named ACL, we say, and look at this other powerful command here. Like I've always mentioned, no is a very powerful command in networking, and we use it to negate any statement or to undo. So if you want to remove the previous access list, we'll just say no access list 10, and that will remove all of that access list. So we want to implement a standard named ACL. So like I told you, you don't start with access list this time around. Keep on checking where IP is and where IP is not. So you say IP access -list, IP access -list, IP access -list. Just a minute here. All right. Okay. So we'll say IP access -list, IP access -list, and we once you say IP access -list, then we must state whether it is standard or extended. Okay. And like I told you, always try to put the name in capital letters, no spaces in between them. You just need to uh, give it in capital letters so that everything is actually okay. Now, so look at the second statement. It's actually beginning with remark. And remark, we use remark for explaining for us or giving a description of what the ACL actually means. Okay. So it's important, of course, for us to note that the name, the description must always be given. Okay. That is going to help so many people, not just you. Anyone who will come after you will always know what that particular access list actually mean. So that's why it's important to always give the description. Now, you can see the second step. So we say ACE remark. ACE permits host 192.168.10. Once we do that, we now go to the permit statement. We now go to the permit statement, and we do for the permit statement, we now permit one host. So here you just say permit. So one of the differences that I need you to note that you first have to give a remark, and then the permit statements are actually you put them on a different line. That is one difference that you always note with this particular ACL. Because if you don't do that, then you'll actually be configuring the standard. You'll be configuring the standard. So we put permit host, that one, and here you can see there's a difference. Either you can use host, then put the IP address, or you put the IP itself. And once you put the IP, then you can now just put the 0.0, the code 0, one-card mask like we saw. Okay. So we have also another remark is permit all hosts in LAN 2. We are going to permit a whole host. And once you do that, we can now be able to permit the whole network. We say permit 192.168.20.0. And when you put 20.0, the wildcard mask, of course, has to be present. The wildcard mask has to be present. So that is, of course, just important. Now, sorry about that. So the next thing you have to do, like I told you, you must now place it on the interface. So you say interface, for example, serial 10. Then once you put the serial 10, then you go on and you say, and look at that difference here. We say IP access hyphen group. Say IP access hyphen group. Then you must put the name. You must put the name. And once you put the name, you can now be able to put the name and then the direction. You can see the direction. The direction is out. Now I will be explaining to you, of course, how do we know out, or how do we know in? But the difference here, IP access hyphen group, we just put the name, and the name must be exactly how it was up here. The name must be how it was here. If you put a different name, it will not actually pick it up. And then, of course, the direction will be in, which means inbound, and out means outbound. Okay. That is okay. This is left. All right. Now, so let's now pick it up on modification of ACLs. Of course, I think I want to open a particular, let me work on a particular activity here so that we can see exactly what happens here. So look at this. We have this particular activity here, and R1 connected to the internet, and R1 on the left is connected to LAN 1 on network 192.168.10.0/24. LAN 2 interface G001, and that is 192.168.20.0. All right. And we need to look at what is the condition that we are given here. We are going to configure numbered and named ACL on R1. Look at that. So look at the instruction, and of course, I'm going to read for you the instructions here, which says that you'll create a numbered ACL that denies host 192.168.10.10. Look at that here. That is this host here. We want to deny this host, but permit all other hosts in LAN 1. This is, of course, this is LAN 1. All right. So, of course, you know, this is LAN 1. We want to deny only this guy, but we are going to permit all other hosts in LAN 1. And we'll start by configuring the ACL, and the number is 20. And we are going to deny the specific host first using the host keyword. Now, a few house rules here. A few house rules is now listen to this. When you're configuring your statements, permit and deny. When you're configuring your statements, permit and deny. The rule number 1, make sure that all your statements are not just deny statements. Make sure that all statements are not just deny statements, that you don't even have one permit statement. You know what that's gonna do? The router has a policy called the implicit deny statements, whereby the router puts at the end of all your access lists, you can't see it, but the router puts a deny all statements. What does that mean? It means that if all your statements are deny, you say deny Florida, deny Leonida, deny Malcolm, you know what that means? It means that for the router, if every statement begins with deny, even those that were not denied will actually be denied. Even those that were not denied will actually be denied. So you should never have all your statements denied, because even those that you have not denied will be denied. And that's why, if all your statements were to be denied, make sure you place another statement at the end that permit any. So permit any other person. That's what it means. So deny this, deny this, deny this, and then you say permit anyone else. All right. So that is something for you to note. The other thing for you to note is, let's say I have the whole network. Maybe that network is network 192.168.10.0. And one of the PCs there is 192.168.10.10. So 10.0 is the network. 10.10 is one of the IP addresses belonging to one of the devices. Listen to this. You cannot deny the whole network and then you come and permit one of them. Okay? You cannot deny everyone else and then you say permit one. Okay? If you deny everyone, then you come and permit one, it doesn't make sense to the router. The fact that you have said deny everyone, the second statement will not apply. So the moment you say deny everyone, it's like you say, everyone get out of class. And then you say, Malcolm, come back to class. It can't happen because you had said everyone get out. And that's exactly what the router will do. Or you say, everyone, like you permit everyone, and then you want to deny one. That doesn't work well with the routers. So what am I trying to say? Access control list work from specific to general, which means permit or deny a specific IP, and then you can now come and permit and deny the whole network. So start with a unique, a specific one, then come for a general one. You cannot start with general, then you come to specific, because it will not work in that order. So those are a few things that you want to note. All right, so let me, since we are doing standard, we have been told to deny, look at this, we have been told to deny this PC here. But because standard ACLs only tell us where traffic is coming from, the source IP, it doesn't tell us deny it to where. And that is one of the disadvantages of standard, okay? We'll just deny it from going anywhere, and that is not a very good strategy. But anyway, let's look at, let me just zoom the page. And yeah, so let's start this. So you'll create a named ACL that denies host 192.168.10.10, but permits all other hosts on LAN 1. So you say, remember the way we start named numbered ones, you say access hyphen list, access hyphen list 10, access hyphen list 10. Then you say deny, and you're going to start by denying, sorry, it's number 20, we are told. Access is 20. Deny, you're told to use the host keyword, and we are only denying one host, which is 192.168.10.10. All right, we press enter, and that's it. Remember, extended ones will start with IP access hyphen list, but standard, actually the ones that start with IP are the named ones, the ones that are named. But all the numbered ones will start with access hyphen list. And then you have to create a second numbered ACL. So we say access hyphen list 20 that permits all other hosts in LAN 1 on network that one. So access is 20. So let me just start this to tell you something. Let me reset it and come back here. So you say access hyphen list 20. Sorry, deny. So I want to explain that you can either say host 192.168.10.10, or you could just say deny 192.168.10.10, sorry, 10. Then you say wildcard mask will be 0.0.0.0. That is still allowed. But remember, in this instruction, we have been given very clear guidelines to use the host keyword. So that's why we're not going to use the second method. So you say deny host 192.168.10.10. All right, enter. Then we create a second numbered ACL. You say access hyphen list 20 deny, sorry, deny all hosts. So you say we now use the network address 192.168.10.0. You put the wildcard mask of /24 0.0.0.255, and that's it. Oh, there's something I didn't do. Access is 20. Deny 192.168.10.0. Let me just say access hyphen list 20. Oh, we were supposed to permit, not deny. That's a mistake. Permit 192.168.10.0. Wildcard mask is 0.0.0.255, and that should be okay. As usual, after we configure it, we now need to place it on the interface and listen to what we're told. Because the ACL 20 policy only applies to traffic from LAN 1, the ACL will best apply in coming to interface G00 of R1. And let's discuss that. Now, one is we are going to apply that ACL. It only applies this traffic. So we're going to put it here on G00. And someone will ask, what if we put it on S010? What will be the disadvantage? If you put it on S010, remember, traffic from LAN 1 is going to come to G01, and we don't want to do that. And if you apply it on G01, traffic from G00 is going to have the freedom to move to the internet. But you're told we need to deny that particular PC and permit everyone else. So to have a maximum impact, we're going to put it here, G00, and put it on this router. And the direction, look at this. Traffic is coming from LAN to R1. So we want to know whether it is in or out. You must ask yourself, is that traffic coming into the router or it is leaving the router? If you put it on G00, you know it will be getting into the router, so it will be in. If it was put on interface G01, it will be getting out of the router, so it will be out. So that is one thing you must always know, all right? In and out is something that has made people to do many mistakes. So we are told we'll put it on G00 and apply it inbound SL20, and then we need to return to the global configuration mode. We are told to use G00 as the interface designation. So we say interface G0/0/0, enter. We say IP access hyphen group. It was group 20, and we say in, just like that. IP access hyphen group 20 in, and that is that. So we need to return to global configuration by just exiting, and then we are creating another ACL. We are now creating a numbered ACL. So we need to say create a named standard ACL that permits host that one. So remember, this is now a number named. This is IP access hyphen list. And since we are talking about standard, we must start with standard. Say standard. Then we say we put the name, and the name we have given, you can see here, is LAN2 hyphen filter. So LAN2 hyphen filter. LAN2 hyphen filter. Press enter, and now we're going to put our permit statements here. So you say create an ACL that permits host that one. So you say permit host 192.168.10.10. All right. Then you have to deny all the hosts using the any keyword. So you just say here, deny all other hosts using the any keyword and return to the global configuration mode. So you just say deny any. Since when you're configuring access control list, it's very different than when we're configuring standard extended. In extended, you'll have to say what is the source of the traffic and what is the destination of the traffic. So you say deny any, which means deny anyone coming from any source. We don't know about the destination. So you say deny any, then you say we exit to global. And then the LAN2 filter will be best applied outgoing to LAN2. So what are we told it was doing? Let me just say. We're told create a named SCL standard that permits host 192.168, but denies all other hosts access to LAN 2. Now we are talking about access to LAN 2. So look at this. Traffic should move from here. We want to permit it from this PC here. We need to permit this PC to go to LAN 2, but we need to deny any other traffic from going to LAN 2. So you realize this. If you place that SCL on G00 and we say permit one device from going to LAN 2, we might permit everyone else. We might deny everyone else here. We might permit this PC. So by putting it here, putting it on G00, yes, we'll be permitting it from going to G01, but we might also permit it from going to internet. That is one, which is okay. But what about all the other hosts? We are told deny everyone else. So we'll be denying everyone else from, if you put it on here, yes, we'll deny everyone else from here. But remember, we want to deny everyone else from just going to G0, from LAN 2.
we don't want to deny everyone from going to the internet. Okay, listen to that. Let me say that again. We are told permit only one person to go to LAN 2 from LAN 1, but deny everyone else from going to LAN 2. So if you put it on G00, yes, we'll be denying PC1 from going. We'll be permitting PC1 from going to LAN 2. Okay, but we'll also be permitting it from going to internet. We are told to deny everyone else from going to LAN 2. Now, if you deny it at G00, don't you think it will be not only be denied from going to G01, which is LAN 2, we'll also deny them from going to the internet, yet that is not our intention. Now, if you put that access list on S010, we will be permitting it only here. But if you put it here, yes, it will still be able to, traffic will still be able to move from G00 to G01. That is true. But traffic, since we put deny here, traffic will still be denied from going to the internet, yet that is not the original idea. Remember, the original idea is to deny them from going to LAN 2. And that's why how access lists can become a bit complicated. Okay? It is very sensitive. Make sure you check where you want your access list to go to. Why am I saying that? Because if you put it in the wrong interface, it will be denying or permitting traffic that will otherwise be needed to be denied or applied. So denying everyone else from going to LAN 2, you must put that access list here on G01 so that any traffic from LAN 1 that needs to go to the internet, let it go, so long as it cannot come to G01. That is very, very important. So traffic will still go to the internet, but only traffic from the whole of the LAN except PC1 will be denied from going to LAN 2, So I needed to explain that to you. Why? Because that's exactly what we want to do while configuring here. So we are told, and before I do that, let me just explain for you the direction. So when you put it on G01, and this traffic, remember, it's coming from the router to this LAN. Remember, the reference is always the router, which means traffic will be getting out of the router. And that's why it will be out. The direction this time will be out. When it was coming from LAN 1 to R1, it was in. But now that we're putting on this interface, it must be out of the router. So that is something very, very important for you always to remember. And that's why we are told here that the LAN 2 filter will be best applied outgoing to LAN 2. So use interface G001 and apply ACL outbound and return to global configuration. So you say interface G0/0/1, then you say IP access hyphen group, and group was, the name is LAN 2 hyphen filter, and you see out, and you press enter, and then you exit to the global configuration mode, and that's it. So, this is something very, very important for you to practice, and I want you guys to experiment as much as possible. You'll be employed in some networks whereby, let's say the firewall has been ordered, but it's not yet there. And they tell you, as with your experience as a network administrator, configure for us, please, some access controllers to give us some security while we don't have a firewall. So that is something that you're gonna need to be doing. And on that note, I would like you to try some two ACLs here, very simple ones. One is 518, and 519. So the first one is for numbered ACLs, numbered standard, and the second one is for named standard. Please try those two. Try those two and see basically how do they work. So 518 and 519 are two ACLs standard. One is numbered and one is named. One is standard and one is named. I'm just trying to open them. They are very simple instructions here. And actually, I think they have the commands for you there. So this one actually looks like this. This is the 519. Very simple. All commands provided here for you, and you don't have a reason to work on it. Even the names of the ACLs have been given here for you. So they have queued everything for you, and you just need to swallow it. So try this, work it out, and just try to see. This is for the named standard. The one for numbered standard, of course, is actually here. The one for numbered, this is for, numbered standard. Again, very simple. Almost all the commands are again given to you here. And I have no doubt in my mind that you guys can, of course, be able to work it out. And even the troubleshooting, you'll see some of them will be succeeding the pings and some of them will fail. And that is because access control list have actually been configured here. So work out this, practice with it. Standard is a bit straightforward, like I said, and everything should be okay. Please work on it until you get to be to 100. That is 518 and 519. I think Leonida will record that and put for you guys in the WhatsApp group for you to practice. So do that, and just for you guys to learn. Otherwise, I want us to do the last bit, which is the part for extended ACLs. And before we learn about extended ACLs, of course, we need to see how do we just a minute. How do we modify ACLs? Two methods of modifying ACLs. You must have made some corrections probably. And this is where I was encouraging you guys. Make sure the text editor is a very good friend of yours. So one, you could go back to your text editor, like Notepad, and just try to edit the ACLs you had created them. If you had written a wrong number, or you can just go there and edit it, like editing any text document. Or you could do this using sequence numbers, and this is where sequence numbers come into play. Like I told you, every permit or deny statement, the router gives is a unique number. Like the first one has been given sequence number 10. The second one is given sequence number 20. The third probably given sequence number 30, 40, 50, all the way. So let's say, instead of saying deny 192, you use to 19. Instead of saying 192.168.10.10, you use 19.168.10.10. And you need to edit this using sequence number. So what you need to do, you go to the global configuration mode and you say IP access -list standard 1. All right. Since the access list standard here was actually 1, it was number 1, which is standard. All right. Then you say no 10. The moment you say no 10, which is the 10 is the sequence number here, that access list will actually be removed using the sequence number. And then you put a new one. Now you say 10, which is the same sequence number, deny host 192. You correct it here from 19 to 192.168.10.10. And then you say end. So when you say show access list, you now say your standard ACL number 1 is now going to be denying 192. So you have corrected this from 19. From 19, you've actually been able to what? To change it to 192, and everything is now okay. So that's how you can always use sequence numbers to be able to edit your access control list. Now, you and I know very well that access control lists must be placed on an interface. But you also know that SSH and Telnet are always configured on line VTY. And so we can also have access control lists configured specifically for VTY lines, which will be permitting or denying other people from accessing your device using SSH, and you only permit you as the network admin to access your device using SSH or Telnet. So we're gonna learn about some standard ACLs for Telnet. So here, of course, you'll have a username, for example. Those who were there yesterday, we created a username. Then you say privilege, then you say secret. So you say username, you could ignore the part for privilege, for example. You say username is admin, secret is class, so secret is the password. Then you create your standard access list. This is a named one. You say IP access -list standard. Then the name is admin -host. You can give a remark here. This ACL secures incoming VTY lines. That's okay. Then you could now permit one host device, say permit 192.168.10.10. Then you must say deny anyone else. So you only permit your PC and deny anyone else from using SSH in your network. So you'll go then to line VTY 0 to 4 and you say login local. Remember, this is for SSH, it means login using the local database of usernames and passwords created here. Then you need to say this command, we used it yesterday, transport input telnet. Yesterday we say transport input SSH space telnet. You can also just allow only telnet. Then you say to place the ACL, listen to this, guys. To place the ACL on a VTY line, you can't say IP access -group. You don't do that. For the line VTY, you say you don't use IP, you say access -class. Very important. Access -class. Put the name of the ACL, which was admin host. Then you put the direction is in. In is the direction. Access -class, admin host is the name, then in is the direction. All right, that's very, very important. Now, so here you are restricting anyone from ever accessing your device through telnet, except you. For those who are there yesterday, we learned of how telnet in the previous class. Telnet is very insecure because you'll actually read everything that someone was trying to do. But by configuring a telnet and having an access list for it, if someone is using Wireshark, they will still be able to see what you're doing. So be very careful, even when you're using telnet in your network. Otherwise, let's talk about extended ACL. This is the last one we're going to be doing, at least for today. So talking about extended ACLs is a very interesting affair. We still have, of course, numbered and named. And like I said, extended ACL provide a greater degree of control of your network, and they will filter based on so many things, including both the source and destination IP addresses, protocol types like IP, TCP, UDP, ICMP, and even port numbers. So like I said, extended ACLs can still be grouped under numbers or names, whereby for numbers, you start with the access -list, put the number, which must be from 100 to 199. And then the named ones, of course, you start with IP access -list and you put extended and then you put the name. So let's see what that means. Okay. Yes, I'm in class. I'm in class. All right. So look at the range of how many protocols here can actually be permitted. And this is just a small list. So when you say access -list 100, which is extended, permit, put a space and put shift and question mark, you'll see port numbers from 0255. And then we have so many protocols there. Some of them are familiar. Some of them we'll be talking about them soon, like DMVPN. We'll talk about GRE. There's ICMP here. We know about IP. We know about OSPF. We did during our previous classes. We know about TCP, UDP, and the list is much, much longer than this normally. So let's look at an example of how to configure extended ACL using numbers. Now, before I do this, I think, okay, let me do it after this. Let's see an example. This is an example of how to configure an extended ACL. So you'll need to say access -list. It's list 100. Permit. Then you'll have to tell us whether what you want to permit, is it a TCP protocol or a UDP protocol. So you must start with a TCP there. Then you must put the source and then you must put the destination. Did you see that? In standard, we only use the source. We don't put the destination. In here, you will say access list 100, permit TCP traffic. And we don't want to permit all TCP traffics because we have so many protocols under TCP. One, we want to state the source, which can be host IP address, using the word host and you put the IP, or it could be a network address and a wildcard mask as the source. For the wildcard for the destination can also be a host device, one device IP address, or it can also be a network address and a wildcard mask. Then you put out of that TCP traffic. What is this TCP traffic going to be equal to? What is the specific one? So the specific TCP traffic we want to filter is actually a HTTP traffic. So for HTTP, you can either use the number www, all right, or use 80, the same thing. When you put port 80 or you put www, it is still the same thing. It is still the same thing. Okay. So so that is actually very important for this particular configuration. All right. So access is 100. This is another one. We now want to filter traffic based on actually SSH traffic and HTTPS traffic. So for that, we'll say access list 100, permit TCP traffic from any source to any destination equal to 22. We could use 22 here, which actually means SSH. Access is 100, permit TCP from any source to any destination, and the specific TCP traffic should be 443, which means that will be HTTPS. All right. So like I said, this extended access control list, they give you a greater control of your network. And that is something that every security admin wants to note. Greater control of your network. How do you place them on the interface? The same thing. Like I told you, just by configuring these statements here, doesn't do anything to your device. You have to go to the interface, for example, G0/0/0, and say IP access-group and use the number, which is could be 110, since here is 110 here. All right. And you must put the direction in or out. So in this case, it's in. And then your access list is complete. All right. That is very important. Now, I need to explain one thing because we do have the word established here, and I want to explain to you the TCP established extended ACL. So let me use this diagram to explain it. Let's say you are browsing to a web server that is far away. So you click a particular link to visit a web server that is in the internet. When you click the link is loading on your PC here, okay? And then the link has to come back so that you can now be able to display what you are actually browsing. Or you send a ping. You send a ping message by pinging a device that is on the internet. So you send the echo requests and you need to get an echo reply. So you send an echo request and need to get an echo reply back to your PC. So this return traffic, we call it an established traffic. What is an established traffic? An established traffic is traffic that was requested from the internal part of the network, the inside part of the network, which means it was initiated from inside to outside, and we are expecting some feedback. So the feedback is what's called an established traffic. That means any traffic that is originated from the outside part of the network coming into the internal part, that is not established traffic. And much of that could be hackers trying to access the internet part of your network, and you really want to prevent that. And that's why every time you permit traffic going out, remember to permit it coming in, because you need that feedback, and that's what we call established traffic. So to allow traffic that was requested from in to come back, we'll say something like access list 120, permit TCP from any source, anywhere. And when you say anywhere, most of the case, this could also include the internet, from anywhere to our network, which is 192.168.10.0 with the wildcard mask here, and the traffic is actually established, which means this is traffic coming back to our network from anywhere, from any source to our network here. And we say that we put the word established at the end there. So we need to go to our interface and say IP access group 120, then use the word out. And this can be very confusing. If this is your router here, this is the internet, okay? This is internet, and your router is connected to the internet. So this is your router. And then there's, of course, a switch here, and then there's a PC right here, okay? So if you had pinged a device in the internet and the ACL was put on this interface, maybe this is interface G0/0/0. So when traffic will be coming back to your router, then as it gets into your LAN here, all of this will be your LAN now. Remember that traffic is now coming out of the router to your LAN. That's why we're using the word out here, okay? The ACL is, if it's placed here, it will be coming out of the router. If you had put it here, then that traffic will be coming in. That traffic will be coming in. All right. So when you say show access list, of course, you'll see extended IP access list is 110, and the sequence number 10 was permitting TCP from this network to anywhere from our network going outside, and traffic was equal to HTTP. This is web traffic. Then the second ACL was permitting the returning traffic, which is permitting TCP traffic now from our network to any. Okay, oh, this is the second one. Again, from our network to any. The first one was web traffic for HTTP. The second one is web traffic for HTTPS. Okay, and you look at this. This is very important. Every time a certain traffic getting into your router, the router records the number of matches that ACL is being matched. Okay, so if you using extended ACL here, we are now permitting TCP traffic. This is the one that this is access is 120, which is going to permit TCP traffic now coming from anywhere back to our network. This was the return traffic, and is the one that was having the established keyword. We have had 1,166 matches all through. So any traffic originated from the inside must be permitted coming back to the device. Now, let's look at a named extended. Okay. Now, for a named extended, okay, for a named extended, we are basically going to use a name. So let's see what happens here. So we are going to create a name, say IP access-list, and it is an extended one. So the name is surfing here, and we remark it, permits inside HTTP and HTTPS traffic. So you see permit TCP traffic coming from this network 192.168.10.0, and the wildcard mask is there. So this is the source network and the wildcard mask, and the destination is actually any destination. It's equal to 8. Then permit TCP traffic from 192.168.10.0 with the wildcard mask here to any traffic, and we are talking about to any destination, and we are talking about traffic HTTPS, that is still web traffic. One is secure, one is not secure. That is the first ACL. The second ACL is called browsing. So you say IP access list extended browsing. And the remark is only permit returning HTTP and HTTPS traffic. So that is the description. So we say permit TCP traffic from any source to this destination here, 192.168.10.0 to this wildcard mask, and it should be unestablished traffic. All right. So we exit, and then we need to go and put both of them on the interface. So we say interface G00. We say IP access group surfing in. Surfing is in, and access group browsing is actually out. Browsing is out, and after that, if you say show access lists, of course you will see that the extended IPs list called surfing, it was having two ACLs. The first one is permit TCP from this network using this wildcard mask to anywhere, and that was HTTP www. And the second one was from this network, any part of the network or any destination, and that is HTTPS on 443. And the established traffic is permitting TCP from now any source to back to our network, and it is actually an established traffic. It's actually an established traffic. So this is very important, just for us to be able to note. So this is for named extended ACL, and that is basically how we do the configuration. So I will be demanding more and more practice from you. I'll give you more activities for practicing, so that we can be able to learn how to do that. Now, before anything else, I actually want you guys to show you some examples of what you guys will be working on. But before I do that, I could just probably do one on VTY, and then I could give you to practice the rest. So let me just do this on online VTY. All right, so we are told create a local database entry for a named admin, and class is the secret. We say username admin, secret is class. All right, so we need to create a named standard ACL, and the name is admin host. So we say IP access list, and this is extended. So we're gonna say extended. This is admin host. All right, we did check something. All right, IP access list extended admin host. So say IP, let me just do that again. IP access list. Oh, it is standard, sorry. Standard. And you say admin host. All right. Then we need to create a permit ACE host with this IP address. You say permit host, and the host is 192.168.10.10. All right. And then you need to add an implicit deny statement. Very, very important. You say deny any, okay? And we return to the global config mode, and we need to get to line VTY 0 to 4. It's given there. And you say use the login local method authentication and permit telnet. You say login local, and we need to permit telnet traffic. You say transport input telnet. All right, transport, the spelling is wrong. Transport input handlet. Good. We need to restrict inbound access to PC1 only using access class command and named ACL admin host and return to privilege exec mode. So we say access -class. Remember that? And it is class. The name is admin -host and in, because it's inbound, and we need to return to privilege exec mode using and we are told that PC1 attempted to telnet to R1 and was successful. PC2 attempted and was unsuccessful. Verify the ACL statistics to see if the ACLs were working as expected. Of course, we are just verifying access list. Say show access -lists, and you can see that there are 2 matches for the first ACL and 2 matches for the second ACL. Of course, the sequence numbers are right there. All right. Now, as a gift for Friday, I would like to give you some few PTs here to work on. Again, these ones, they are provided for you the commands. Very, very generous of Cisco here. They have provided for you the commands. So the first one is the one for extended. I think the first scenario will be for numbered and named. It's just opening now. This is the first scenario opening here. This is, by the way, 5412. This is 5412. Very simple one. All commands provided and guaranteed. Very, very good. Everything step by step. In fact, you type a command, put a question mark. Type a command, put a question mark, because they want you to understand exactly what you are doing. Very, very nice practice here. Please get to learn more about it and configure. This is 5412. This is 5412. Then the scenario 2, also for extended. This is for extended. Again, this is named. Let's just see it here. It's opening. All right, it's opening here. All right, it's opening. And I could just zoom it again. Yeah, this is another one. This is on 5413, and you're also going to, configure some to servers that are within the internet. Again, commands provided for you, everything here. So with this in practice, commands, everything provided for you. I don't think you guys should have a reason not to know how to configure extended. And in the field, I think you configure more extended than ever before. And if you can do that well, then I will be more than willing. To now give you a trial and give you a challenge. This is an ACL challenge. I'll give you an ACL challenge, and I would like to challenge you to try and figure this out. For this one now, we have not given the commands. The commands are not given. You're gonna have to figure them out. And what a good challenge for you guys. Very, very interesting work here for you guys to figure out. There's HQ LAN 1, HQ LAN 2. There's new company, headquarter network, branch 1, branch 2, so on and so forth. So figure this out and come with those commands here, for ACL. And I want to see you guys getting 100 over 100 here. This is very good work for the weekend, which means the weekend should not be a bit lazy. Try to make probably on a Sunday afternoon after you've gone to the mosque or to the church, try to work on this ACL. This is a very good challenge before we meet on Monday. Yeah, I don't know what is on the packet tracer physical mode. Let me find out what's here. packet tracer physical mode, I think it will be a very good another for those of you who want to exhaust all your fee that you pay at Kenyatta University. You might want to try the physical mode is here and figure it out. So you're gonna create this topology, 2 switches, 2 routers. The 2 routers are already here. And of course, I think they have been connected for you. 2 routers, the first router is here, the second router is here, and the 2 switches are here. What you need to do is you need to use the cabling provided here to connect them in this way. And you are given instructions here to do some good job here. And guess what? This work is very interesting. For those of you who want to review, work that we did in CCNA 2. This work will let you configure some VLANs, all right? Configure some trunking, configure routing, both OSPF and static routing. You'll configure SSH, remote access. You'll verify, and then you configure extended ACLs. You guys are very lucky. And this is a wonderful. Basic settings are still here. And VLANs configurations, so trunking, routing. Oh my God, you'll even configure inter-VLAN routing here. Route on a stick, if you remember. So guys, if I were you, I will be more than willing to work on this. Look at SSH configuration is also here. So this is a whole summary up to where we have reached. Then of course, you're gonna configure now SSH. Access control is down here. You don't want to miss this. This is another gift for you. And this is 551. Sorry, that's not 551 is the challenge, challenge. And there's another challenge on 552. 552, the blue one. The blue one is an interesting one that I would like you guys to put your hands on. Put your hands on them. And I want to do that so that when we get to the next chapter, which is NAT, where we'll actually be implementing access control still in NAT, I want you to already have knowledge of ACLs because we will need it in the next chapter. Chapter 6, we'll need it in chapter 6 because that is very, very important. So do some work on that. And let me see you guys on Monday when we will be talking about NAT. We'll talk about NAT on Monday. And after we do that chapter on chapter 6, of course, we will need to have a physical lab. You guys will tell me when you guys are free to come for the physical lab at our city campus here. Otherwise, I don't know that there's any questions. That will be a very good point to end this class.